Ladies and gentlemen, welcome to the next session of our tech session. For Q&A, kindly key in your questions at the Q&A chat box. Do visit our virtual exhibition and discover the latest water innovations and technologies. The exhibition will be live for 24 hours during this whole week. Do enjoy the next presentation.
Okay, good afternoon, everyone. Have a nice lunch. Welcome to the tech session under the Malaysian International Water Convention 2021. My name is Engineer Ilyas. I'm a council member of the Malaysian Water Association. Okay, with us this afternoon, we have a session on integrated sewage treatment system for small communities. This will be presented by Professor Dr. Shamsul Rahman Muhammad Kuti from University Technology Petronas, Malaysia. A brief introduction of his CV as presented here. Professor Dr. Shamsul Rahman Muhammad Kuti is a lecturer in civil engineering at University Technology Petronas. He received his PhD degree from the University of Memphis, Tennessee, USA. He has worked with the University of Petronas for more than 20 years. He is popularly known as Professor Shark. Kat mana Shark ni? Due to his various involvement in theatre. Wah, ini sudah jadi lama ni. Nevertheless, throughout the years, he has been involved in research and consultancies related to wastewater treatment, biological as well as physical chemical. Over the years, he has also been invited to give talks locally and overseas on wastewater treatment. He has obtained several research grants from MOE under ERGS, FRGS, and PRGS. Sorry, I don't know those acronyms lah, which will culminate into commercialization of the products. Right. Okay, welcome, Professor. Please carry on with your presentation. Thank you.
Thank you, sir. Okay, let me share my screen. Okay, ladies and gentlemen, Assalamualaikum and a very good afternoon, to everybody. So my presentation today is on integrated suspended growth bioreactor for sanitary wastewater treatment for small communities. And my name is Professor Dr. Shamsul Rahman Muhammad Kuti, or they call me Prof. Shark. All right. The picture that you see there is a microbial, right? It's a microbes called rotifer. Right, it's a higher organism. We are a higher organism, but under the microscopic level, that is one of the higher organisms. Yeah. So, an activated sludge system. What is an activated sludge system? It's basically composed of an aeration tank. Right. This is the aeration tank. That is the aeration tank, and a sedimentation tank. It's combined together. Right. It's basically a suspended growth aerobic system. When you say suspended growth, means the microbes that you breed. Yes, we are actually breeding microbes in the aeration tank. They are in the suspended mode, right? They are in suspension throughout the whole tank. All right. So the purpose of activated sludge system is basically to stabilize the wastewater, which have organic matter constituents. Where do we get this organic matter? From our toilets. So our toilets basically provide the food for these microbes in the influent coming into the aeration tank, right? So because they are very nutritious, yes, but not for us, okay? Not for the human beings, but only for the microbes, all right? So this is a picture of an aeration tank. Of an aeration tank, you have an empty aeration tank. You have the fine bubble diffusers there, right? These are all fine bubble diffusers. And these diffusers is basically to provide oxygen from the compressed air. So it's basically, it's coming from the atmosphere, it goes through a compressor, and then this air goes into the fine bubble diffusers and to provide oxygen for the microbes, because the microbes need oxygen. Why? Because they are aerobic like us. We need oxygen as well. The second reason is because to provide mixing of the biomass. We call them biomass. These microbes, they are a bunch of microbial species, organisms, so we call them biomass in the aeration tank, right? And you can see here, these are a tank full of the biomass, and you can see those bubbles here, those are actually the bubbles coming up from those fine bubble diffusers. And the color of the liquid there, all right, is brownish, all right? The brownish color shows that there are microbes in the tank. If you see it's colorless, that means there's no microbes in the tank, all right? So what happens in the tank? Basically, the microbes degrade. Okay, basically they eat, but we don't call that eat lah. We call them degrade the organic matter, which is the carbonaceous, into various gases and cell tissue. And this cell tissue is basically a little bit greater in the specific gravity than the water. So then it will settle down in the sedimentation tank. All right. So what happened was, in the aeration tank, these beautiful microbes will use this oxygen here to degrade these chons. And this chons is our wastewater. Right? It's basically our wastewater. And when they degrade this, what's going to happen? You're going to produce water, clean water going to go out. Carbon dioxide goes to the atmosphere. Ammonia. Now there's ammonia coming. Oh my God, we are producing ammonia now. And small children. We're going to have more microbes growing. So basically the aeration tank is where we breed the microorganisms. All right. Just now I mentioned about the ammonia. What happens to the ammonia and the nitrate? This is what happens. So this is basically the concept of what system that you need to choose. All right. The ammonia, you can further oxidize it to nitrite, right? With the help of another microbes called nitrosomonas, and the nitrite can be further oxidized to nitrate with the help of nitrobacter. These microbes here are slow growers. This is very important, that when you conduct or when you run your activated sludge system, you must maintain at a long sludge age. What is long sludge age? I'm not going to go into details of that one. Maybe you go to another course, right? So that long sludge age is basically connected to this system, extended aeration activated sludge system. So in this case, if you have a limit of ammonia in the effluent, because here after degradation or oxidation of ammonia, you are only going to get water, energy, that's all. So what's coming out of the treatment system is basically water and carbon dioxide, nothing else, and remnants of the ammonia. So in this case, if you have a limit on ammonia, you must implement extended aeration system. Or there are so many varieties of extended aeration system. You can implement oxidation ditch. Right? There are so many others activated sludge system. There are about 11 or 12, maybe more than 12 activated sludge system depending on the contractor. Right? Now, again here, oh no, we are now producing nitrate. Now we need to get rid of nitrate. If you have a nitrate limit, because now we do have limits on nitrate, yeah, ammonia nitrate in standard A and standard B in the DOE requirement, yeah. So how do we remove the nitrate? The nitrate can be reduced to nitrogen gas. These microbes here, nitrosomonas and nitrobacter, they are called nitrifiers. Okay, nitrifiers. They are slow growers. That means you need to use a long sludge age. But for nitrate to be reduced to nitrogen gas, you need another type of microbes, which is denitrifiers. All right, and you need another tank, which is the anoxic system. All right, so you need to have anoxic system. So there are so many varieties of activated sludge system where you can have anoxic prior to the extended aeration, or after the anoxic tank, or you can have alternates. So there are so many different types, which I mentioned earlier. Yeah. Now, so let's recap what's happening in the whole system, in the activated sludge system. So first, you have oxidation, which is the degradation of organic matter, which I mentioned earlier. The chons, which is your wastewater. Microbes is using the nutrients as well, yeah, to carbon dioxide, water, ammonia, and more microbes. And then you have the synthesis, where these microbes are growing, right? That is a microbes growing. And then you're going to have your denitrification, which I mentioned earlier. Now, then if you have your anoxic tank prior to the aeration tank, you see this ammonia is going to be degraded to nitrate. So you're going to have a lot of nitrates here. So you're going to have an internal recycle. So I'm telling you the concept of an activated sludge system if you have anoxic in front, all right? And you're going to have your raw wastewater coming in, and the nitrate is going to be reduced to nitrogen gas in the anoxic tank. And then the process will go through the sedimentation tank. What happens in the sedimentation tank? Because as I mentioned earlier, they are growing and growing, so you need to settle all the biomass. So this is the concept of an activated sludge system. So now the components are anoxic tank, aeration tank, clarifier. Oh, one more thing. You are going to have waste sludge. You're going to have waste sludge. So this waste sludge has to be taken care of. Yeah, you have to throw them out or into a sludge thickener. So that's why you may want to have a sludge digester. So you have four components, four important components here. So now the prototype system that I'm proposing is basically a circular annular biological wastewater treatment that integrates the anoxic tank, aerobic tank, clarifier, and sludge digester into one system. And this system is the ISGBR, right? That is the system that we have in place right now in UTP. And this is the integrated suspended growth bioreactor, which integrate all the four components earlier. It can be accommodated for low organic loadings and of wastewater. It can occupy less land area to meet the new effluent standards for ammonia and nitrate, as well as sludge disposal, where this reactor here is basically a prototype, yeah, not a pilot plant yet. We are going to impose, or we're going to have clients where anybody is interested to collaborate, please contact me. This is a pilot plant. That is how tall my student was, and 6 feet tall, right? So about 6 feet, and you have all the four components of activated sludge in there, right? This is the testing of the prototype. So how does it work? Well, remember I mentioned to you about the anoxic tank prior to the aerobic tank, and then you have the clarifier, right? And then you have your anaerobic sludge digester, the digester where you have the waste sludge and you have the clarifier. So you have 1, 2, 3, 4. And these are the integration of all the components into one system. So that is my student taking the sample, yeah, from the effluent from this system. So the requirements for maintenance, you need basically air diffusers, anoxic tank. You can also include attached growth media. In fact, in the aeration tank as well, you need sludge recycle pump, internal recycle pump, the feed pump, and you may require grid removal and bar screen prior to using this system, yeah? And you can include an automation system, SCADA system. So these are the results for the COD. The COD is basically about 1,600 here until 2,400. We have tested this, yeah? And then we are having, this is the influence COD, right? And this is the, what do you call, the volumetric loading. So the influence COD is 1,200 approximately, but we meet standard A, right? Standard A COD. For the TSS profile, ammonia profile, the ammonia is also meeting standard A, right? and as well for the nitrate limits, because in this case, we have introduced the anoxic tank. So we are also removing the nitrate. And the market potential for this product will be communities that practice open defecation. Yes, there are places still in Malaysia that do that. Yeah, special markets, small markets, islands, small scale industries that produce organic load, because some industries produce organic load, so they have to treat their own wastewater. Yeah, small settlements, rest areas, small communities with septic tanks, because nowadays septic tank is not good enough to remove ammonia and nitrate. Yeah, and schools. So this is another market that we can cater for. Yeah, so these are all the customers that product which produce organic load, which has to handle space limitations, and those places that are without centralized sewage treatment system. Here we compare all the technologies within ISGBR, the product, the septic tanks, the small scale activated sludge systems, and the large scale activated sludge systems. So in this case, the footprint, you're going to have 35 to 40% footprint savings. The performance is meeting standard A. In fact, it's better than standard A. Yeah? Maintenance costs, minimal and very ease of operation and versatility. So globally, we still have a problem in wastewater. Yes, look at the figure. You still have places where you have open defecation. You still have places for unimproved wastewater treatment systems. All right. So there are global market for the product. This have already been patent applied for. I've already applied for patent for this particular product. Publications which has been done by my student on the product on this ISGBR. This is just a summary of the product, my poster. Yeah, basically my poster, which consists of everything which I have told you before. Wow, what is this? I love this microbe. This is called a water bear, right, ladies and gentlemen? It has 8 legs. Now, this particular guy is very dangerous, where they can be dead for years and they can be alive again. They can be resurrected. All right, they call themselves tardigrade or water bear. In my life, I have seen twice. Okay, there were 2 times where I've seen this in my students' reactor, this water bear. Yeah, so I leave you with a water bear. Thank you so much. If you have any questions.
Prof, they haven't put me on video. Okay, coming on now.
Okay.
Am I on now?
Yes, yes,
yeah.
you are.
Okay, good. Okay, Prof, very clear, concise lecture. I'm sure all your students in your class semua score A. No problem. And UTP producing very good graduates. First priority in the market. Now, your talk today, your invention, with pre-reminder about the processes for some of us who are not in the sewerage industry. Your invention is good. Now, I want to look at a question that's been posted on the chat. Is there any question posted on the chat? How many people are actually watching? No question posted on the chat, Prof. You've got 69 people watching your presentation.
69.
Okay, sorry. There's one question. One question coming up. Hi, Prof.
I don't see them at all, yeah?
Yeah, it's from Alia. I'm not sure where she's from. She only put her name there. Hi, Prof. Maybe your student. Approximately how many PE can this system cater in your study? I also wanted to know the size that you showed, just for sense of magnitude and maybe power requirements. What's the PE there? Yeah.
All right. Basically, the prototype system that we constructed was tested at the an industry in Bemban, Batu Gajah. That system is a prototype, but we designed it only for 50 PE, 50. But At the moment, we are proposing with a company to upscale it to about 500, only about to 500 to 1,000 maximum. So we are catering for that range of PE, 500 to 1,000 population equivalent.
Okay, second question from Rahmat Shazi. Assalamualaikum, Prof. Have you / UTP's Rio identified the MVP and the low-hanging fruit target, i.e., who will want to buy it first? I tak faham RIO and MVP, maybe return of investment or something like that. Yeah.
Okay, Dr. Rahmat Shazi is my friend. I did not plan that question. Yeah, I invited him to the talk, and he's also a theater guy. All right, he's also an actor, director, scriptwriter as well, like me. But now he's no longer in UTP. Basically, he knows UTP's research enterprise office, yeah, a research innovation office. Yes, UTP has identified the low-hanging fruits and who will want to buy it first. At the moment, we are applying for a pilot plan. And then we're gonna test it at IWK Penang. At the moment we are testing at IWK Penang for the prototype, and we're applying for funding from the government for a pilot plan. Okay, for a pilot plan. So we are talking to companies to do that. There's another one there. Does the product obtain approval from SPAN? For approval from SPAN, the procedure is we need to construct the pilot plan. Yes, we are in the process of getting the approval from SPAN once we get the pilot plan up and running. Yeah.
Okay. No questions. I'll just throw mine in, slot in while somebody punch in another question. Prof,
Okay.
the material stainless steel ni memang high grade and very long lasting, superb. But at the same time, I know many STPs or small sewage treatment plants are made from FRP and perhaps similar materials, which are also performing so far. Have you considered those angles? Because most plants would like to be buried underground. One reason could be you save a bit on pumping costs, perhaps. Although maintenance-wise, whether yours is feasible or not, being underground. Can you comment on that?
Yeah.
Thanks.
Yes, basically you can do it underground as well. At the moment, we are talking to these companies. They do not prefer that to be FRP. They say that it can be disintegrate over a period of years. So I don't know. They know better lah. But to me, I would prefer FRP lah. But because maybe it's much more cheaper. And then yes, you can do it underground as well. As long as the pumping system is working, then it should be okay.
Oh, no more questions. Takkan nak stop dah, Prof. Maybe you.
Anybody? And how many people there now?
Now I think I still let me look at it. 72 now. Ada naik lagi after lunch. Yeah.
If there's no question, I will give them a quiz.
What's the prize money? I wouldn't want. I would like one treatment plant. Put it, somewhere. Donate it to some community. Yeah. Go on, Prof. We have time here. You can keep going for one. Yeah.
Okay. Basically, the treatment system we have already tested for industry. For industry, the industry is only for production of wastewater which has organic content. When you say organic, means it does not have heavy metals. So the organic, for example, from beverage industry. All right, beverage industry, small scale industries, because they cannot discharge their wastewater to the IWK treatment plant. They are not allowed to, right? And they have to have their own wastewater treatment, effluent treatment system. But if they do not have enough land, right? So this system can actually be higher up. Right, we can go up instead of going horizontally. So this is also useful for small-scale industries, not just for small communities. For small communities, we know that they don't have heavy metals, they don't have toxic wastewater discharge from domestic. Yeah. So, but we are catering only for small flow, because for the large flow, you need to use the IWK large treatment system. That is okay. But only for the small communities, this is very useful, especially for schools. Yeah, for small schools, because septic tanks are not good enough to meet their our wastewater treatment limits, especially ammonia nitrate, BOD, TSS. Ammonia nitrate. That's why we have a lot of kangkung growing along the longkang, because you're gonna have a lot of ammonia, phosphorus coming out. Yeah.
Questions, please come in, questions. Otherwise, I keep on chatting with Prof lah, because I'm also in the sewerage, not so much a big player, but interest lah, more interest than consultancy really, especially small treatment plants community, because many ways sustainability means, decentralized plants, that's what they seem to say, and also perhaps a lowering of energy pumping costs and resources, piping, things like that. Treat it where it is and then reuse it back there.
Yeah.
People talk
exactly.
about community toilets, things like that. But I would, go on, Prof.
There is a question there.
Okay.
For standard A or B. All right. Okay. For standard A, you have 2050 and standard B 50/100. 2050 is your BOD TSS, yeah. And then for ammonia, you have 10 and 20, yeah, 10 and 20, and standard B ammonia nitrate is 2050 as well. But for this system, we can actually meet below standard A. Right, I promise you. In fact, most of the activated sludge systems that IWK has, right, running an extended aeration, you can actually run below standard A, much better than standard A, not just standard A. Yeah, standard A is 2050. You can actually get 2 and 3. Okay, 2 and 3 instead of 2050. 2 is your BOD, 3 or 5 your total suspended solids. If you install a filtration at the end, your water coming out will be like tap water, right? It's basically like tap water, like drinking water, but you cannot drink those. Yeah, you do not drink those because those are still having a lot of viruses. Right, even though they don't have microbes, but we can see they still have viruses. We do not
coronavirus ada.
Corona. Well, basically they have found that these coronaviruses do exist in the wastewater, so they are basically in a very dangerous position right now. Those workers. So I just hope the degradation in the aeration tank will kill also the viruses. But then again, I think we also need to implement our wastewater disinfection. It's timely enough for us to impose wastewater disinfection before we discharge to our rivers lah. With this corona going on, yeah.
Ada lagi ni, siapa? No more questions
No more.
The session is actually 2:30, Prof. I think anyone wants to know further, they can always contact you or contact through MWA or ProTem. Thank you very much for your sharing of invention. May success come towards this venture. And thank you very much, Prof. And thank you everyone else for watching. Pass it back to the organizers. Thank you.
Thank you so much. Thank you everybody. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.